Hi guys, welcome to this Easy Maths video where today we will be looking at the UKMT Senior Maths Challenge 2017 paper. There's going to be 3 parts to this video. So we're going to have the first part, which is going to be questions 1 to 10, second part, which is going to be questions 11 to 20, and the third part, which is going to be questions 21 to 25. So let's get into it with the first question. So one of the following numbers is prime. Which is it? A is 2017 minus 2, B is 2017 minus 1, C 2017, D 2017 plus 1, and E is 2017 plus 2. So I think to start off this question, we should just go through each of these scenarios, A, B, C, D, and E. And we should try and find whether we can see if there's any multiples of these numbers. So if we start off with A, obviously 2017 minus 2 is 2015. Well, this number ends in a 5, so therefore we know that 2015 is a multiple of 5. Therefore, we can say it's not prime. So next one is 2017 minus 1, which is 2016. Now, straight away we can see that this number is even, so therefore it is at least a multiple of 2. Therefore it's safe to say that this number is also not prime. Now C is 2017. Now this one isn't so obvious. It doesn't end in a 5, it doesn't end in a 0. So we know it's not a factor of 5 and we know it's not a factor of 10. It's not even, so we know it's not a factor of 2, 4, or possibly even 8. One thing we can do, though, is there's this trick to test whether any number is a multiple of 3. And I've done a video on this, and I'll leave a link to that video in the description below. So what we can do to test whether a number is a multiple of 3, we can add up the digits. 2 plus 0 plus 1 plus 7, which is 10. And then if this number is a multiple of 3, we know 3 is a factor of 2017. But of course we've got an answer of 10. So therefore, it is not a multiple of 3. We can also say it is also not a multiple of 9. I mean, there's no way to fully confirm that this number is prime. But if we have a look at the results for D and E, and we definitely know that those numbers aren't prime, then by the process of elimination, we can say that C is prime. Of course, there's more tests you can do. You could divide 2017 by many different numbers, try and see whether you get a whole integer with no remainders, and then you could determine whether it's prime or not prime. But that's very time consuming, and especially in this exam you do not want to be doing that. So if we have a look at D, which is 2017 plus 1, which is obviously 2018. And again, we can say the same as we did for B. It's even, so therefore it is at least a multiple of 2. I'm not too interested in what other factors of 2018 there are. We know it's at least a multiple of 2, therefore it's not prime. And E, the last one. Now this 2017 plus 2, which is 2019. Okay, so it's not even, so we know it's not a multiple of 2, 4, 8. It doesn't end in a 5 or not, so it's not multiples of 5 or 10. But what we can do is we can run our test to see whether 2019 is a multiple of 3, like we did for C. So if we do 2 plus 0 plus 1 plus 9, we get 12. Now 12 is a multiple of 3, so therefore 3 is a factor of 2019. 2019 is not prime because we know it has a factor of 3. So by process of elimination then, we can say that C is the prime number. 2017 is the prime number. Therefore, answer equals C. Okay, question 2. Last year, an earthworm from Wigan named Dave wriggled into the record books as the largest found in the UK. Dave was 40 centimetres long and had a mass of 26 grams. What was Dave's mass per unit length? Okay, so we know that Dave's mass per unit is 26 grams. And we know that his length per unit is 40 centimetres. Now, both of these figures are for 1 unit, and we need to find what Dave's mass per unit length is. So what we can do is we can divide the mass per unit by the length per unit. Therefore, mass is 26 divided by 40. And of course, this simplifies to 13 over 20. But looking at our answers, we've got A is 0.6 grams per centimetre, B is 0.65 grams per centimetre, C is 0.75 grams per centimetre, D is 1.6 grams per centimetre, and E is 1.75 grams per centimetre. All of our answers are in a decimal form. We can't simplify this fraction any further without converting it into a decimal. But what we can say is we know what half of 13 is. We know half of 13 is 6.5. And of course, if we divide our numerator by 2, we need to divide our denominator by 2. So if we divide 20 by 2, we're going to get 10. And of course, we're going to get 6.5 over 10 is equal to 0.65. And because it's mass per unit divided by length per unit, our units are going to be grams per centimetre. Yeah, we've got that answer. Our answer is B. So therefore. Okay, question 3. The 5 integers 2, 5, 6, 9 and 14 are arranged into a different order. In the new arrangement, the sum of the first 3 integers is equal to the sum of the last 3 integers. What is the middle number in the new arrangement? We've got our answers as A is 2, B is 5, C is 6, D is 9 and E is 14. So if we break this question down a bit and try and understand exactly what it's asking us to figure out. So we need to take these integers 2, 5, 6, 9 and 14. And what we're saying is the sum of these first 3 integers, 2 plus 5 plus 6, which is 13, should equal the sum of these last 3 integers, 6 plus 9 plus 14, which is 29. Obviously 13 does not equal 29. So what we need to find is we need to find a result where the first 2 numbers in this arrangement equal the sum of the last 2 numbers in the arrangement. If we take these numbers to be A, B, C, D and E, if we take the sum of A, B and C, and then we take the sum of C, D and E, what you'll find is the C's cancel out and you're just left with A plus B equals D plus E. So what this means is we need to find a number that has no effect on the sum of the first 2 terms in the sequence and the sum of the last 2 terms in the arrangement. So I think in order to find the solution to this question, we're going to need to test for each of the cases. We could then do a test for B, to see whether 5 is the middle number. So if we have 2, 6, 5 is our middle number, and then we've got 9 and 14. So 2 plus 6 is 8, 9 plus 14 is 23. That doesn't work. So we'll try the next result. Don't need test for C because we've already tested it up here. And we know that 6 is not the middle number because 13 does not equal 29. So let's test for 9 being our middle number. So we take 2, 5, 9, 6 and 14. We're going to get 2 plus 5 is 7. We're going to get 6 plus 14 is 20. They don't equal each other. Okay, so now let's try 14. If we take 2, 9, 14, 5 and 6, we get 2 plus 9 is 11, and we also get 5 plus 6 is 11, which is what we want, because we want the values of A and B to equal the values of D and E. And what I think you'll find is that the values of 2 and 9 and 5 and 6 are our only pair of integers with the same sum. So therefore, we can say 14 is our middle number, and our answer is therefore E. Okay, question 4. Which of the following is equal to 2017 minus 1 over 2017? We've got A is 2017 squared divided by 2016. B is 2016 divided by 2017. C is 2018 divided by 2017. D is 4059 divided by 2017. And E is 2018 times 2016 divided by 2017. Okay, so when I see questions like this, rather than focusing too much on what the numbers are, I try and find a way in simplifying this term. Rather than solving this fraction with the numbers 2017, let's replace 2017 with a variable. So if I let 2017 equal to x, I can then replace my expression with x minus 1 over x. I can then simplify this. If I write this as x over 1, I can then simplify this by multiplying my numerator by x and my denominator by x. So I get x squared divided by x minus 1 over x. This then simplifies to x squared minus 1 over x. And what you'll notice here is we've got a difference of 2 squares. So that then simplifies to x plus 1 multiplied by x minus 1. And now all we need to do is just replace x with 2017 again. So we've got 2017 plus 1 multiplied by 2017 minus 1 divided by 2017. And of course, that gives us 2018 multiplied by 2016 all over 2017. Therefore, our answer is equal to E. Okay, question 5. 1 light year is nearly 6 times 10 to the power of 12 miles. In 2016, the Hubble Space Telescope set a new cosmic record, observing a galaxy 13.4 thousand million light years away. Roughly how many miles is that? Is it A, 8 times 10 to the power of 20 miles, B, 8 times 10 to the power of 21 miles, C, 8 times 10 to the power of 22, D, 8 times 10 to the power of 23, or E, 8 times 10 to the power of 24? So I think in order to solve this question, we need to break down the question a bit more. So what information have we been given? We are told that 1 light year is nearly 6 times 10 to the power of 12 miles. We're then told a galaxy is 13.4 thousand million light years away. So, in standard form, we know that 1,000 is 10 to the 3. We know that 1,000,000 is 10 to the 6. Therefore, 1,000 million which is 1 billion, we can say is 10 to the power of 9. So we can rewrite this as 13.4 times 10 to the 9 light years in standard form. So now what we need to do is we need to work out roughly an estimate for how many miles that is. So we know that 1 light year is 6 times 10 to the power of 12, and we need to work out how many miles 13.4 times 10 to the power of 9 is. So therefore we can multiply 13.4 times 10 to the 9 by 6 times 10 to the power of 12. But what we need to do first is we need to change this form slightly, because what will happen is we'll multiply the 13.4 by 6, which is roughly 80, I think. And of course, none of our answers are in the form of 80. We need to put 13.4 times 10 to the power of 9 in a form where 6 multiplied by something will roughly give us 8. So what we can do is, because we know 13.4 times 6 roughly gives us 80, we can move the decimal point in front of the 3 and then move that 10 over to here as part of our standard form. So rather than writing it as 13.4 times 10 to the 9, we could write it as 1.34 times 10 to the power of 10. So now what will happen is the 1.34 times the 6 will roughly give us 8. But then we need to work out what 10 to the power of 10 times 10 to the power of 12 will give us. Well, this is just basic indices. If we take a to the power of n times a to the power of m, we know that this is going to give us a to the power of n plus m. So we can apply the same concept here. We can just add the powers. So 10 to the power 10 times 10 to the power 12 will give us 10 to the power of 22. Therefore, an estimate for our answer is going to be 8 times 10 to the power 22 miles, which we've got an answer for, and our answer is therefore C. Okay, question 6. The circles in the diagram are to be coloured so that any two circles connected by a line segment have different colours. What is the smallest number of colours required? Got answers of A is 2, B is 3, C is 4, D is 5, and E is 6. So what I've done is I've enlarged this diagram just to get a bit of a better understanding of what's actually happening here. So what we can see is that this triangle here is our smallest root, because we've got 3 circles connected by 3 lines. And what's going to happen is, because all 3 of these circles are connected by 3 line segments, all of these circles are going to need different colours. So if we label this as C1, for colour 1, this is C2, and this is C3. We then know if this circle is C1, then this circle has to either be C2 or C3. Well, if I make this C2, then I can't make this circle C3 because it's connected to another circle that has the colour C3 by this line segment. But what I could do is I could call this C2, and then I could call this circle C1. And as we can see, the 4 circles C1, C2, C1, C3 are all interconnected by different line segments with different colours. So that means I could then label this as C2, and then I could label this as C1, and that would fit the criteria. Therefore we have only used 3 colours to show that any 2 circles can be connected by 1 line segment. So therefore, my answer is B. Question 7. The positive integer k satisfies the equation square root of 2 plus the square root of 8 plus the square root of 18 equals the square root of k. What is the value of k? We've got answers of A is 28, B is 36, C is 72, D is 128, and E is 288. So, what we need to do is we need to try and simplify these surds. So root 2 is in its simplest form, so we can just write that out again. Then we know the square root of 8 is the same as saying the square root of 2 times 4. And we know that the square root of 18 is the same as saying square root of 2 times 9. What then happens is this then simplifies to 2 root 2, because we've got the square root of 2 multiplied by the square root of 4, which gives us 2 root 2. And then we've got 2 multiplied by 9, which is the square root of 2 multiplied by the square root of 9, which simplifies to 3 root 2. And that is equal to root k. And because all of these values have the same root, they all have root 2, we can simplify this to 6 root 2, which is equal to root k. And now we need to find what our answer for k is. So we can simplify this expression by squaring both sides of the equation. So if I square this and I square this, I'm going to get 6 root 2 times 6 root 2. 6 times 6 is 36, and root 2 times root 2 is 2, which is 72. And of course, root k squared is just going to give me k. So therefore, k is going to be 72. Therefore, my answer is C. Question 8. When evaluated, which of the following is not an integer? We've got A as 1 to the power of minus 1. We've got B being 4 to the power minus a half. C as 6 to the power of 0. D as 8 to the power of 2/3. And E as 16 to the power of 3/4. So what we need to do is we need to go through each of these answers and see whether we can simplify these indices. So the first one, A, 1 to the power minus 1. Anything raised to a negative power means that we need to find the reciprocal of that number. So the reciprocal of 1 is 1, and then that is just going to be raised to the power 1. So 1 to the power 1 is obviously 1, and 1 is an integer. So that's not our answer. We look at B. B is 4 to the power of minus a half. Now and again, we need to find the reciprocal of 4 in order to simplify this expression with a positive power, which is a quarter raised to the power of a half. And then we can simplify this by taking the square root of 1 and the square root of 4, so we get a half. And of course that's not an integer. So we would think our answer is B, but let's just check C, D and E. So C, we've got 6 to the power of 0, which is always 1, which is an integer. And we've got D, which is 8 to the power 2/3. So we need to take the cube root of 8, square that. Cube root of 8 gives us 2, 2 squared is 4, which is also an integer. And then E is 16 to the power of 3/4, which is the 4th root of 16 cubed. 4th root of 16 is 2, 2 cubed is 8, and 8 is an integer. So therefore, our answer is B. Okay, question 9. This is a pretty difficult question if you don't understand what is fully going on here. So I'm going to break this one down quite carefully. So the diagram shows an n times n plus 1 rectangle tiled with k times k plus 1 rectangles, where n and k are integers and k takes each value from 1 to 8 inclusive. And we need to find the value of n. We've got answers of A is 16, B is 15, C is 14, D is 13, and E is 12. So this is our rectangle, which is n by n plus 1. And then each of these tiles, which all vary in size, are k by k plus 1. And we're told that the values of k lie between 1 and 8 inclusive. So what that's pretty much saying is rectangle with the highest area will be 8 times 8 plus 1, which of course is 8 times 9, which is 72. You're going to have a rectangle of 7 times 8, you're going to have a rectangle of 6 times 7, 8 times 6. You get the idea. So, what's going to happen is the area of all these rectangles from 8 times 9 all the way down to 1 times 2 is going to equal the sum of the area of n times n plus 1. So we can write that as n times n plus 1 is equal to the sum of k times k plus 1 from k equals 1 to 8. That is strictly what we're saying here. We're saying that the area of all these rectangles from 1 to 8 is equal to the total area of the whole rectangle. So we need to simplify this expression. And we can do that by taking each term. So the first term is going to be k is equal to 1. So that's going to be 1 times 1 plus 1, which is 1 times 2. And we're going to plus 2 times 3, plus 3 times 4, plus 4 times 5, plus 5 times 6, plus 6 times 7, all the way up to 8, plus 7 times 8, and then plus 8 times 9. Okay, so if we simplify each of these answers, so we've got 2 plus 6 plus 12 plus 20 plus 30 plus 42 plus 56 plus 72, we'll find that this result gives us 240. Now we can say that n times n plus 1 is equal to 240. If we expand this bracket here, we get n squared plus n equals 240. Bring the 240 over to the left hand side, we get n squared plus n minus 240 equals 0. And then we need to factorise this expression here. But what we know is the value of n is going to be any of these answers up here, so 16, 15, 14, 13 or 12. We know from this expression we're going to get two values of n, one being positive and one being negative. So we'll make that n minus something and n plus something, and then we can test each of these answers. So let's try 12 and 13. Okay, so we know that would have to be 12 and that would have to be 13 to be left with n. 13 times 12 is 156. But we need 240, so we know that isn't our answer. Next we could try 13 and 14. 13 and 14 gives us 182. That doesn't equal 240, so we can try the next answers. 14 and 15. Is 210. And last ones we'll try as 15 and 16. Now 15 and 16 is 240. Now, and you could have worked this out using the quadratic formula, but I think to save a bit of time maybe in this exam, it would probably be better to do a bit of trial and error. You know that n is going to be any one of these values. So we're going to have n as minus 15 and n plus 16. So if we expand this out, we're going to get n squared plus 16n minus 15n minus 240. Therefore, n equals 15 or minus 16. Well, we know that the value of n can't be negative, so therefore our answer must be B, 15. Question 10. A rectangle is divided into 3 smaller congruent rectangles as shown. Each smaller rectangle is similar to the large rectangle. In each of these 4 rectangles, what is the ratio of the length of a longer side to that of the shorter side? We've got A is 2 root 3, B 3 to 1, C 2 to 1, D root 3 to 1, and E root 2 to 1. What I've done is I've enlarged the rectangle, and when I was looking at this question I saw that we weren't given any values, so I decided to call this Y and this side X, kind of like a pair of axes. And the question says that we've got 3 smaller congruent rectangles. Now congruent means that they're identical. So something else we can say is if we call the whole rectangle R1, and then we divide each of these smaller rectangles as R2, R3 and R4. We know that the length of each smaller rectangle is going to be equal to the width of the larger rectangle. R2, R3, R4 are all going to have lengths of Y. Now, because these smaller rectangles are similar to the large rectangle, their widths are going to be a third of the width of rectangle 1. So rectangle 2 is going to have a width of 1/3 x, R3 is going to have a width of 1/3 x, and R4 is going to have a width of 1/3 x as well. And the question says that we need to find the ratio of the longer side to the shorter side. The ratio for rectangle 1 is therefore going to be xy. And the ratios of R2, R3 and R4 are going to be Y 1/3 x, Y 1/3 x, and Y 1/3 x as well. These ratios here are the same as saying 3y to x. So now what we can say is that the sum of these ratios is equal to the ratio of R1. So therefore x to y is equal to 3y to x. Now we can sort of rewrite these ratios in a fraction form. So we can say that this is x divided by y, and we can say that this is 3y divided by x. And then what we could do is we could, in order to simplify these fractions, we could multiply the left hand side by x, multiplying both the numerator and the denominator. So we get x squared divided by x times y. And then we need the same denominator on the right hand side, so we're going to need to multiply top and bottom by y. So we get 3y squared divided by xy. And then of course what happens is those xy's cancel out, and then you're left with x squared equals 3y squared. Now I want to find the ratio of the length of a longer side to that of a shorter side. Well, I know my ratio is x to y. So if I rearrange this, so I've got x to y as my subject, so I get x squared divided by y squared equals 3. I can then square root both sides, so I get x divided by y equals root 3. And of course, this is the same as saying root 3 divided by 1. So therefore, my ratio of x to y is equal to root 3 to 1, which is my answer up here, which is D. So therefore, my answer is D.